Okay, let's go ahead and get this started. So we've gone through the first two parts already of this. And in case you have not seen this video before, this is going to be um, helping with exponential modeling, where we have something that we know is growing exponentially, and we have two instances at 20 minutes and at 35 minutes. The first video in this series went over how you came about creating the exponential model that we have here. What this model is going to, what this question is going to go over is some classic scenarios when you're given some input or some output here. So in this case, our inputs are our number of minutes, and our output is how large that bacteria culture is. If we continue on here, I'm going to do both parts with this one. When it asks for the 70 minutes, what it's really saying is, given this model, what happens if x is 70, right? So I'm going to use the exact one up here, even though it is more cumbersome, simply because because it'll be exact. And if we want to know what it is when x is 70, what that means is we replace x with 70 wherever we have this, right? So I can put that in there like this. So one way to handle this problem would be to take the whole thing and kind of send it through in Desmos. Another way would be to go, well, tell me what f of 70 is, and then off we go with it. So those are two ways that Desmos can kind of help you with that piece of it. The next part would be how do you deal with the output. This is another thing that I actually find quite good with Desmos. You can take the result there and then copy and paste it in there. That's really good, I find, when you have these kind of cumbersome values and you really don't want to memorize that 32,771.5928, just not really into it. And we're on the second piece here. Remember, our inputs have to deal with number of minutes. Our outputs have to deal with how big that bacteria culture is. So when it gives us a scenario where we have a bacteria culture that is 11,000, well, that means that our function itself is equal to 11,000. So if I were to take this thing over, it would mean setting f of x equal to 11,000 like this. So we want to figure out what value of x will this work at. If we go back, right, so let's go back before I manipulate this quite a bit. Let's go back and take a look at, well, what is this, right? And when it comes to its core, what we're dealing with is some 11,000 equals our initial times our growth factor here. So our steps, when they're simplified like this, should be a little easier to sort out. I want to solve for this thing, so I have to get rid of my coefficient here. So I'm going to divide both sides by that coefficient, right? So in this case, I'm going to divide this thing over by this, which is not so great, but we can do that, right? So we can divide, say, that thing over. And the next thing we're going to do is we want to solve this for x, which means we want to get rid of the base value here. And if what we have here is this little hot mess, there's really two ways to handle that. You can take a common logarithm of both sides, or you can take a log base of something very specific. I'm just going to take a common logarithm because each of you are going to have a variant on it, and I don't want someone to get a slightly different version. But notice that it's going to be quite messy in there, right? So, that's me trying to keep an exact answer. I would recommend that when you're doing homework online, because you're just dealing with mechanical processes that will look for an answer that is right to a certain amount, and the more you kind of estimate it, the more you round it off, the less likely automatically it'll accept that answer. But we took the common logarithm really to solve for that variable x, and then move that exponent in front of the logarithm, which is one of our log properties. And the next thing is we're going to have this. So if I want to get rid of that, since I'm multiplying by it, I need to divide that over to the other side. It's a pretty common tactic. And since I want to know what this is, if I get to the front, I can see that x equals this 57.611 bit here. That's about as complicated as I think you're going to see that. So hopefully seeing me kind of go through it and talking it over really helped out. Of course, if there are any questions, go to the discussion board, send me an email, and I'd be happy to help you out further. Yeah, I hope you're all doing well with it, and have a good day.